Hello everybody! So today we're going to be learning about chain rule. Let's write it up here. Chain rule is basically the same thing we learned in algebra, or the concept of what we learned in algebra of composite functions. If you've never heard of a composite function before, I would really recommend going back to either YouTube, Khan Academy, or Calc Workshop and look at composite functions and what they are, how to solve them algebraically. So let's talk about what a composite function is. A composite function is a function, f, and we're going to use another color because we have visual learners here, f of g of x. Whoops, we have a function within another function. So this red function is completely interwoven within this black function. So it's a little bit more complicated than just a simple f of x, right? We have two functions. So when we're dealing with calculus and taking derivatives of functions, we know if we have just a single function, we do power rule. So we're going to go over a little bit of review of the power rule. So say we have x squared. We know by power rule that if you take a derivative, d dx is our way of telling the reader or the person that's doing math, take a derivative. So this problem is saying, take a derivative of x squared. And we're like, okay, x squared is a single function. I know how to do that. This is power rule. Power rule tells us you take the exponent, you bring him down, and then you subtract the exponent by 1. So we'll do it. You bring him down to x, and then you subtract it by 1, which is the same thing as 2x. So right there, we took the derivative of x squared, and we know it's 2x. That's by power rule. So that's super cool. But now, we get to problems where you have functions within other functions. And then things get more complicated because we can't just do the normal power rule. We have a lot more stuff to consider. So let's just throw an example out there and we'll walk through it. So let's say we have, let's erase this and we'll start fresh. Let's say we have, take the derivative of 3x minus 1 squared. We're like, okay, this is a little bit more complicated than just an x like it was in the first problem. We have an inside piece right here that has stuff in it and then a power. So we have an inside piece and an outside piece. So we're like, wow, ding, 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 this is chain rule. We have a function within another function. Chain rule. Step 1, you gotta identify that it's chain rule. Then we're like, okay, how do we handle this problem? You gotta think to candy, my friends. Think of an M&M. When we think of M&Ms, we have this candy coating shell, and then we have chocolate inside. You can't get to that chocolate without eating the candy first. So we're gonna think the same thing for chain rule problems. Chain rule equals M&M candy. Cool. So in this case, this 2 is going to be the candy coating. It's the outside of the problem. This, the red, is the inside. We have to think back to order of operations. In order of operations back to algebra, we have to deal with exponents first, then parentheses, and then multiplication, addition, everything else on the inside. It's the same thing with calculus. Algebra rules never go away. So what we're going to do the same thing as a power rule, but we have to take it a little bit slower. We have more to consider. So the power rule says, take your exponent, bring it down, and then subtract it by 1. So we're going to do that. We are at 2, 3x minus 1, 1. What you noticed, though, was I just dealt with the candy coating, and I left the chocolate completely untouched. So, candy coating, you do your normal power rule, you leave everything on the inside untouched because we haven't gotten the chocolate yet. But now, You completely ate the candy coating, so now we can multiply by then the derivative of this inside piece, or the chocolate. And we know that the derivative of 3x minus 1 is just 3. So to recap it, you have this function. You can deal with the outside portion first, take the derivative of it, keep everything on the inside unchanged, then you can eat the chocolate. So this right here is your derivative. Like, you just took a derivative of this problem using chain rule. But in math, we like to simplify a little bit just to make it look nicer. So we know anything raised to the first can just go away. We have 3 times 2 is 6. So we'll just write 6 times 3x minus 1. And that's a perfectly great answer. You are complete. You took a derivative of this polynomial using chain rule. So let's try one more problem just to kind of see the rhythm of how this goes, because these problems, they come in all different shapes and forms, but they're treated exactly the same. So let's try another one that's a little bit different, but the same process. So we want to take the derivative, d dx, of the square root of 4x minus 1. We're like, that looks different than anything I've seen before, because with power rule, we'd always have a power that we could bring down. I don't have power here. But what we do know, anytime you have radicals, it's the same thing as having whatever's on the inside raised to the 1/2 power. So this is the same thing as taking a derivative of 4x minus 1 to the 1/2 power. If you didn't know that, make sure you star that in your notes, because this is a very important concept that you will see and use all the time in calculus. You see radicals, you turn it into just a 1/2 power, which is awesome. Now, this looks like something we totally know how to do. This looks like the last problem. So what we're gonna do is we're gonna take this power, bring it down, subtract it by 1, keeping everything on the inside the same, and then you can take the derivative of the inside. So remember, this is our inside piece right here, and this is our outside. The 1/2 power is our candy coating, the 4x minus 1 is the chocolate. So we're gonna deal with the candy coating first. We're gonna bring it down, 1/2 times 4x minus 1 to the negative 1/2, because 1/2 minus 1 is negative 1/2. Then you just dealt with the outside. Now we've got to multiply by the derivative of the inside, and the derivative of 4x minus 1 is just 4, which we know. So this again is your final answer, but if you want to simplify it and make it a little bit more nice, we know 4 times 1/2 is 4/2, or just 2 times 4x minus 1 to the negative 1/2. Now, these are the same things just written. This is a little bit more simplified. Now, I have a few more simplification techniques that I really want you to be aware of, so I'm going to star this again. Right here means we got something else I want you to note in your notes. Anytime you have a negative power, it's the same thing as putting this term in the denominator and making this positive. So let me show you a quick example. Say you have x to the negative 2. That's the same thing as doing 1/x squared. You're taking this term and you're throwing it in the denominator just to make this exponent positive. So we're going to do that here just to simplify. So, because negatives, we don't really like negatives in math. They're fine, this is legal, we just don't like them. So this is the same thing as 2 over, we're going to throw this whole term in the denominator and make the power positive. 4x minus 1 to the positive 1/2. And we're like, cool, now it's positive. We don't have to deal with negatives anymore. So that's something to star, this rule right there. One more star, and then we are completely done, and you're going to be masters of chain rule with polynomials. Star number 2. When you start off in a radical, you want to end in a radical. It's kind of just like a nice way. You start and end in the same place. So we know, right away, we took this radical and made it into a 1/2. So at the very end, we can take this 1/2 and make it back into a radical. So this is identical, we'll erase this star for right now, as 2 over the radical of the term. So radical 4x minus 1. We just changed it back to the radical because that's how we started. Not necessary. This whole bottom part is not necessary because this was our final answer, but it's simplified. And this looks nicer to us because it ends the way it started. So guys, you just saw 2 super powerful chain rule problems of polynomials. And there are lots more functions we have to deal with, like trig and exponentials and logarithmic problems, but we'll deal with those later. But this is the first shot you got at learning chain rule problems, and it's super cool. All you gotta do is think of M&Ms. So let me know if you have any questions about the work I did or the worksheet that you have coming up, and you guys are gonna be able to do this. I'm very confident, so.